Okay, there we go. Packet arrived. Time to continue. So there we go. Let me sort myself. We fixed this one almost. It's not fully fixed yet. Gonna continue and re-enable it so that actually works. Again, we don't have a single one which is off or on by default because there's no zero. We have a zero register. That's really handy. We can dump stuff. We can like save it to position 0 and then it will just not be saved. So it's a quite handy tool. Back to flags. Oh, cold. Back to flags, right? So flags. We got 3 different types of conditions: bigger than, equals, smaller than, or the other way around. And we got this and this flag. So now one needs to connect these together in a way that we get conditions which actually met this. So we have some form of output on this side. That's just a single wire, and that is either on or off for jumping or not jumping. Not jumping means increase the program counter by 1, which just means continue in code. Or we jump, that means apply whatever value is here in the ROM. Yeah, okay. Ugh. Getting up was bad. How to do this now? First of all, I should label this, else it would just be confusing. Oak sign. So A smaller b, A equal b, A greater b. So in general, in my CPUs, B is always the bottom and A is the top. So A would be the red one and green is the B one, but that doesn't really matter because I can just put redstone blocks here or just slam these to actually simulate some values for testing. Currently it's 0 by 0, so this one is off. That means if this one is disabled, it's kind of in a way. I'm gonna make this fancy and like a bit later. I need a bit of repeater here, a bit of this, and then we got the first condition here. And conditions in general are an AND gate. The question is, does it have to be inverted or not? Basically, when we want to when we want to compare stuff, we're gonna enable subtraction, which is these 2 wires. Top, no, that wire. We want to have B to be inverted and to be the subtractor, whatever, the one which gets subtracted from the other one. And we're gonna check for equality. There's no equality in real life, but that's not the point right now. There we go. So the combination for equality is currently matched. So what we're gonna do is just exchange this with one single normal wire, and that means we have equality. So this is A equal B. What I'm gonna do now is we're just gonna put some data onto this, and we see there's no more equality because we now got some output here, and that means it's not 0, and not 0 means no equality. Okay, there are more conditions. That's these 2, bigger than and smaller than. The point with bigger and smaller than is it must not be equal. That's very important. For one of them, not for both. So the other point is this wire. Either is on or off. That's the big difference actually. To keep this simple, let's just try. When A is bigger, we got no equal, and this is on. Because A is bigger, we got a positive result, and positive result means this wire is on. But this wire is also on if we have 0. So we need to put this one additional to this one in together. Like we don't want equality, we just want this one on when we're looking for A is bigger B. Else that's no use. But on the other side, we just make B bigger. So now we got B bigger. What's with that output? That's kind of big output. Oh, why it's what have I done? It's a negative result, but yeah, I'm just gonna destroy. Wait, this is 1. Okay, this is 1. So if I do this, we get -1, and -1 is actually this. Perfectly fine. That means this one is off, because then we can see the carry in is actually consumed here, and that means that there won't be a carry out over the carry line. So this one is off, and that means, hey, we got a negative result. Negative result means that A obviously was bigger than B. No, that B was bigger than A, because B is the negative number in this case, because we're doing subtraction, A minus B. And so that's what we get. So these are 2 conditions which we have to do. That one is super easy to do. The what was it called? A minus M, B bigger A. B bigger A is actually just I'm just gonna enable this permanently because there's no use in toggling it while developing it. We just need to connect these up. There we go. Actually, I should enable this again to see how far the signal actually travels. Actually, you can see it's not traveling far enough. So I'm just gonna dampen and repeat it here, and there we go. So this had to be off instead of on. So there we go again. We're just gonna change this to something like this. Perfect. So this is off because B is not bigger. They are currently equal. But destroying this, B is bigger because B is a negative number, which is 1. 1 is bigger than A. Ba-bam, there we go. It's lighting. These look pretty much similar and quite straightforward. The last one is not the kind one in this case. But I don't have much space here right now, so I'm gonna compress this a little bit. But how? Unsure yet. Okay. Just gonna make it like so. I'm gonna put this like here, and this will receive one of these lamps. There we go. Negative number, that's our A, B bigger A. This is the other one, the other fellow. Actually, I'm gonna put that on this side over here because of convenience for now. Put them like this. Just gonna put this out of the way for now. And we just need this, and that, and this, and I'm gonna move this. Oh, there we go. Just gonna wire this up. And attach this. There we go. So there's no equality right now, same as in this world. There we go. Now it's equal, and no longer b is no longer bigger, but both numbers are equal. So this is the point where we got plenty of space for the most complex one. We currently used both of them, but we have to use both combined right now, because what we're aiming for is that A is actually bigger than B. If A is bigger than B, this one is on, and there is no equal. This one is on is quite simple operation to do. That is just this connected to an AND gate. So quite simple. Obviously the end of that AND gate is attached to the control bit. I'm gonna fix this. This is because this is really disgusting wiring right now. So does it reach? Of course it doesn't. No, it does. So currently it claims there is an output. That is actually true, because this one is on, so we get this. Okay, but if we now have equality again, or equal, A is equal B, then this one is also on. That must not be the case. So what we're gonna do is just put something like this, like real simple, just expanding the AND gate condition. Maybe put that extender here again, and so it's off. Let's undo again. We see now it's on because A is bigger. Now it's equal, and the only one left is actually to make it to make B bigger. So that's the three conditions which we need to check, which we can use to get all other conditions which are mostly relevant to us. There are some cases which are also relevant, and that is to check whether there is an opcode. We don't have that. We can check if there's like we can perform operations, any operations which have not for example are not subtraction. We can still check if the result is 0, and we can still check if the carry is not on. So we can check if wait, is this if 0? Yeah, this is if 0, and this is if not carry. But it's not possible for us to check if there is a carry, because then it's also always linked to a non-zero result. Then we could also check if we have carry. So that is kind of a downside to this, but one can actually live with that. One can do quite a lot with this already. It's nicer to actually have combinations of all possible flag positions and stuff, but well, it's fine. Always yawning. Which is not fine is the alignment of all this. It's totally not fine. So it's time to actually, not actually, to improve the situation here by a lot. But how is the question? Because reasons. And this looked so nice in like my learner version. I wanna peek at that to cheat. I'm gonna peek at that. Okay. Heads have been rolling here. Yeah, it's a blank screen. It doesn't matter, I know where I want to go, and that is here. So what I have done over here is, oh, this is okay. This is fancy. I've been wiring these control ones at the bottom and just powering the conditions from below. That's quite fancy. And then just putting that up to the PC because it's a jumping or not jumping. The bigger issue is actually the wires here. So this is the carrier overflow. Oh, funny, it's on this side, so this one is the other way around. I've got this. Oh, this look how fancy this looks. Someone designed this actually. In the middle you got both conditions, which are just torches, and the other one is with repeaters, and that is cool. Some real OCD dude must have done this. Oh, it was me. Time to go back. You're not leaving in an area. Okay, here we go. Well, this is not pretty. Not in a bit. Okay, this is rather disgusting. I gotta get rid of it. I have it in my head how to do it, so I'm just gonna apply that again. But this was more or less more a showcase anyway. Began. Just gonna go down here. Bum 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 bum. It's important if you don't say bam, it's not working. Yeah. This is kind of like really. It would be so much nicer if it's over here or something. It's totally in the way. So I can either put it over here and hope for the best, or somewhere else, but actually it should be somewhere here, so not bad with this alignment. No, it's in the way. Okay, I'm just gonna do this. This is actually okay. It still looks okay. So this is just the bottom part of the AND gate, which just enables the features, and this is just the outputs. So this is really the simple part. I think I have to move it one to the right. That won't fit. So here we go. This is the part where I go like so. Oh yeah, I'm gonna move it. That's totally not okay. This is better. There we go. This has to vanish, and I'm gonna redstone on top and an output. And now it's like really easy to wire this up because of reasons. And if I recall right, it was something like this. Okay, there we go. We got some power over here, which disables this but enables this. We don't have this one connected yet. Just connect it. There we go. So this would be the whole condition unit with invalid stuff. So currently we have 0. This one is the 0 condition. So I'm gonna change the sign. This is A equal B. Because we've flipped this to get this one in the middle because it has the most conditions, so it can just power it from left and right. the other one, it might be that I have to switch these two, but we're gonna see that. So this is actually 0, 0. It means this one is off and this one is off and enables this one. So that actually is kind of correct. The next one would be to have A bigger. If A is bigger, this goes on. Because A is bigger means A, then result is positive. Result is positive means this one is on and the 0 is off. 0 is indeed off means that this one goes off, this lamp, and this one is on, so that means this one goes off. So we check for if it's not 0 and if it's carry, and that means we got A bigger B. That is this condition. There we go. And the last one is the remaining one, which is A is smaller than B, and just simply do that by changing the wires, and there we go. Because in this case the carry is just off. That only happens with negative numbers, and negative result is only the case if B was bigger than A. Perfect. That's the whole branching unit, like the one which decides whether we have to jump or not. With these inputs, pretty simple. And looks nice. That's important. As always. I need water. Good. From this point on, one just has to connect these torches and wire that up to the proton counter. The proton counter, on the other hand, needs one more input, that is the address where it has to jump. So if it doesn't know where to jump, this all is for nothing. Pink, okay. For prettiness reasons, I want to have the jump address here, but this is in the way, so I guess I have to move this a little bit up for this to fit through. So this will be moved a bit. So this is the point where it's in the way. Actually has to be moved up by quite a lot. I should use VE for that. Let's just hook that one and this here and move up 5. We can lower it again later. Did I fail something because there was so much redstone splatter? No. But this was actually too much. We can do 2 less, actually 3. You know, it perfectly goes this way. But this is not real nice. I'm gonna undo again on just move it up 2 times, because now we can just have these here be connected on the same layer, and that is good. In case of this one, I'm gonna find a different way to do it. It's gonna be the same again. There we go. This one can perish, so just need to wire this up. Oh, that's actually fine to put it this way. That's totally okay. Chip connected again. This wire is okay-ish. So we got a little bit of a problem here, but no problem over here. This one perfectly goes here, but this one is not. That's kind of sad. But we believe we have plenty of SS to actually do something. Slabs, right? Slabs are perfect for this. Derb. Typing has to be learned. There we go. Plenty of SS, right? My ass. There we go. Perfect. Okay. Alright. Need these back. Just regards this, I'll have to find a different solution. There are a bunch. So it's just, for example, use this one. Done. Solved. Actually could do that for the others too, but there's no real need for that. Except consistency. Boom, boom, boom. There we go. Okay, I'm happy with this setup. And that's how you get a branch condition unit in here. Like, really simple. Talking is exhausting. Oh, this is neat. It perfectly fits under here next to that. Okay, the program counter. Where and how to attach the program counter? Good question, next question. No clue. I think first of all I have to build a program counter. Because if one is built, it's easy to... What was it? To find a place for it. Yeah. Brown, okay. Let's just put it over here. A typical piston program counter basically looks like this. You got this memory cell, and this can be set and then not be unset. It's been a while since I built the last one, so I'm kind of not sure how to do this. Okay, there we go. I'm just gonna put these here and grab some pistons and just put them on top. And remove the lower one for obvious reasons. Okay. It's like two different modis, and one is incrementation, the other one is disposal. No, yeah, reset actually. The question is which side is which. So what one does here is he puts something like repeaters in this manner, which means if one of these is on, I said one of these, then I go here and quickly, okay, not this quickly, do this, you can see that it actually shifts, but shifting is not what we want to do. So this is just a shifter which I built. I totally forgot how to build these. It was something similar to this. Ah, okay, I remember. There was some form of zigzag. Like this. Where the wire just went the way over there, and this determines how far it travels. But the signal was also in here. I think the best case is if I copy that instead of guessing. But copying sucks. So in that case, I think I'm forced to actually build an incrementer myself. How about a really simple incrementer? Okay. I think there's one type of incrementer which probably everyone has seen when they start with the redstone. I believe, at least. And that is this one. It's this one. How this actually works is you got something like a pulse. So something like this is the start, and this one like does some binary stuff to actually go there. So this works perfectly fine. As you can see, that's plain binary. Is it actually incrementation or decrementation? I'm quite unsure. The problem is to actually query whether the block is up or down, because if you power redstone through it, it will fail. There's a bunch of ways to fix that. I think it's possible to. Oh, this one is the one which is just the monostable. Weird name for it, but yeah. One would be this. They've got cauldrons. That should work as fine. Yeah, it perfectly works. It does not perfectly work, as you can see. So this is no good solution. One way is to use sand blocks. Sand blocks actually work fine. They have a bit of a delay. Where's sand? The 1.14 textures are horrible. This is a little bit slow, but it does the job. And the point is, this won't get stuck if you pipe redstone through it. Because if you pipe redstone through this, it will affect this piston, which is no good. But practically it should be possible to use slime, is it? I'm unsure. Let's give it a try. But I believe slime doesn't block drop. Normally. Oh, that was not the right decision. Okay, apparently this works. Currently. Let's give it a try. I believe this will cause some weird bad effects. Oh, this seems to work. Cool. Okay, there we got a solution. There we go. So what's the next step is actually to have some form of output, and that's just gonna be this one, and I believe we have to invert that thing. And there are some timing issues because this one normally gets always upgraded before that one, and I think it's exactly one tick of a delay. We need to put some delay in here, like so. So no. This should sync stuff. Why is there so much garbage in my inventory again? Okay, there we go. Let's give it a try. All off. 1, 2. Oh, that was wrong. Oh, right. Okay. Okay. Yes, that never happened. You never saw it. Just ignore what you saw. That's the wrong way. There we go. Again, same game. 7, 8, 9, 10, 11, 12, 13, 14, 15, 0, 1. Because this is actually, I believe, decrementing, we invert it to get incrementing. Sounds weird, but it's the case. It just works. Think about it. Try this yourself at home. Actually, don't try this at home, it's dangerous. Okay, it's not. Yeah. But there's a small problem with this, and this is just an incrementer. Actually, is it synced? Yeah, it's synced. It's all at the same time, just the lamps are a bit confusing because they are not synced. So this should be a bit better feedback. Yeah, it's really synced. So this repeater setup also works. Syncing is important, especially at this position. Well, maybe not, but if you have like in a decoder like this one, or like the one over there in the we're gonna use this decoder actually, like literally this decoder, a copy of it. It's synced means if you change a value and then you change a value, another value, so let's go like this, you can see that on the way to the final result we get this flickering, which we definitely not want. If we have flickering, that means wrong data goes into the CPU, and in some CPUs that's a critical issue. In this one it's okay, but it may lead to whatever, weird block drops or whatever, and you just don't want that. You never want that. You don't want weird data trash on your wires. In general, never. So this one can just increment. What you need is actually reset. For this you can just use normal pistons, which are on top of it. Oops. Damn it. I hate this mode. Shift placement is so annoying. Okay, there we go. This is a simple reset. Oh, wait. Is it wrong? Yeah, it doesn't matter. I believe we do this. All of them are on, but it doesn't matter because then you have an input here. Oh, come on. This is actually fun that it's working because this is heavily botting. In An interesting way to reset it would actually something like this. Okay. So this is not the only way to reset it. Point being, we have something like this here. Yeah. Okay, second. Oh, I have to stop here for